Now the rational root theorem, the rational root test can be long when we have a lot of possible roots. In this case, we have 1, 2, 3, 4. We have 8 roots, positive and negative, altogether. Right. Luckily for us, there's a shortcut. Right. And we saw that when we tested for, we tested for x is equal to 1. Right. We had 2. Here's 2. And we had 7. Okay. It was 0, right? So with this shortcut, once we find a root, a remainder of 0, right, which means that x equals 1 is a root or an x-intercept, then what we're going to do is take the highest power here of our function, the degree highest power, and we're going to go down 1. So if it's 3, we're going to take our answer here, our quotient here, take this quotient, take this answer, and turn it into a polynomial. All right? Which will be, well, first we have this factor here. We're going to, so it will be 2x squared. The highest power is 3. The answer will be 2x squared. So we're going to turn it into a polynomial. And the highest power here will be 2. Keep going down in descending order. Minus 7x 1 plus 3. You're done. That will be a factor. But look, this also will, the divisor will also be a factor. So we turn this back on the other side, right? X will be equal to, that crosses out, right? X will equal to negative 1. Okay? That will be our factor. So the goal here is to keep reducing and keep finding roots until the quotient is reduced to a quadratic like this. You want the quadratic to be reduced to a square, right? And once you reduce it to a square, you're going to factor it or use the quadratic formula to get the other 2 missing roots. In this case, we're lucky, it's already squared. So I think you can factor this. So let's try to factor this. I factor it in a funny way. Okay. So for those of you who like this, I'm just showing you this method because I like it. So I like to do it. So I'm going to put 1, 2 together. Nope, it's not going to work. I'm going to put 2 and 1. If you want to learn this method, just contact me and I'll teach you this method. Okay? And it's gonna work. Yep, this is what I'm going to use. So you can factor this to these will be your factors. Okay. Now, the great thing about this shortcut is that it eliminated 5 numbers from here. Let's look at it. We had 8. All of them are gone. You know, now let's try another one. Okay. We did this one previously, and what we did, we did our rational root test, right? We did that, and we had all the factors of 4 and all the factors of invisible 1. And we came out with these roots here. These were all the roots, possible roots. And we tested for x, right? Good, everything's there. 1, 3, -8, 4. we're missing a 3, remember? 3, see, when I go too fast, I mess up too, don't worry. Okay. So since our remainder was 0, x is equal to 1 is a root, right? And what we're going to do is take our answer here, take our q at x, right, which is our answer, and change it into a polynomial. Look at the highest power. The highest power is what? It's 4. So we're going to go down a power. And our goal is to keep reducing until we go down to a power of 2. Okay, so we have this here, this divisor here, and we're going to have this x to the 4th third power, right, plus x plus squared plus 4x first power minus 4. And if you try to manipulate this, you can't factor it any further down. There's other ways to get this. It's called the intermediate value theorem, or the bisection method, right? And you're going to learn that later. So we're going to leave it. We're going to leave it in this way. Let's try another problem. Find all the zeros of this polynomial function. F at x equals to x cubed plus x. That's an invisible 1. We don't need to put that. Okay, first we're going to do our rational root test. And you can try to do it on your own, but you can pause the video and do it on your own. Here we go. Rational root test. All the factors of 12, and all the factors of invisible 1. Factors of 12. Invisible 1. Okay. And we know, since it's a 1, all of it will be 1. So this will be all the possible factors. Okay. So now we're going to perform the rational root test on all of them. Hopefully we get a root, and so that we can take our shortcut. So let's try x equals to 1. And powers are in descending order. 3, 2, 1. Good. 0. Excellent. 1, 3, 4, 12. 1, 1. That's 4. 4, 8. 16. Okay, so this one doesn't pass the test. X is equal to negative 1. Okay, this doesn't pass the test. It's not an x-intercept. Okay, x is equal to 2. It'll be 28. It'll be 40. Doesn't pass the test. Let's keep going. X is equal to negative 2. Negative. Okay, so we're going to have 8. This one also doesn't pass the test. Okay, keep on going. Keep on tracking. Go to 3. That's for x is equal to 3. So we have 3. So 8. It doesn't pass the test. Woo. There we go. Let's try x is equal to negative 3. Hopefully we're lucky. Negative 12. Hey, I think we got something. Haha. this one checks. Okay, guys. So since since our remainder here is 0, then x equals to -3 is a root, an x-intercept, right, for this function here. So now remember our shortcut. Right? What we're gonna do next is take this here. This is our q at x, right? Take it, and this is our divisor here. That's our remainder here. Take our answer and turn it into a polynomial. In order to turn it into a polynomial, you look up here. We see that the highest power is 3. So the highest power for this polynomial that we're going to turn this into a polynomial is going to be 2. So first we got to bring our divisor down, which is going to be x plus 3 times x squared. Go down in descending order, plus 0x to the first power plus 4. Good. We can get rid of the 0, so our answer will be x plus 3 x squared plus 4. Okay, and this can be further divided like this: x plus 2i times x minus 2i. So our roots will be x, set all of them equal to 0, x plus 3 is equal to 0, x will be equal to -3, x plus 2i equal to 0, x minus 2i equal to 0, x will be equal to -2i, x will be equal to positive 2i. So our roots will be -3, 2i, positive 2i. Those would be our zeros for this function. But guess what? Since these are imaginary numbers, they don't count. So our real roots will only be x is equal to -3.